Hello my dear students, this is Rima. Hope you all are doing great. In today's session, we'll be starting chapter number 5 of class 9 CBSE Maths, that is Introduction to Euclid's Geometry. So in this chapter, we'll basically see what is actually a definition of geometry. So geo means land, or basically earth, and metry means what? Metry is measurement. So geometry is a branch of mathematics, right? So how geometry was found? Basically there was a need to measure the land, so hence geometry was found. Okay, so what is geometry? Geometry is a mathematical branch that deals with measurement of properties of different points, lines, shapes and angles. That is geometry. Geometry is also divided into certain branches, and out of that one branch is Euclid's geometry. Euclid is a famous Egyptian mathematician. Okay, so at that time what he did, he actually combined all the works of famous mathematician till that time, that is Pythagoras, Thales and all. He combined all their works and he combined them into a book called Elements. So in this chapter we will study Euclid's approach to geometry. So Euclid studied geometry based on some axioms and postulates. So now we'll study what are axioms and postulates. So to start a definition, he has to start it from some statement which are assumed to be true and not to be proved, right? They are self-evident truth, that is universally that statement will be true. So that is why he has divided that assumptions to axioms and postulates. So what are axioms? Axioms are assumption throughout mathematics. That is, both axioms and postulates are assumptions, but axioms are assumption throughout mathematics. That are obvious and do not need to be proved. Okay, throughout mathematics, obviously true, no need to prove. Now what are postulates? Postulates are assumption. Both are assumptions, right? Both are assumptions of Euclid. Assumptions. Axioms are assumptions throughout mathematics which are obviously true. No need to prove that. What are postulates? Postulates are assumptions specific to geometry. Specific to geometry. Geometry which are obviously true. No need to prove. Axioms apply to all the branches of mathematics, but postulates apply only that are specific to geometry, only to the geometry branch of mathematics. Now we'll see what are Euclid's axioms. Okay, so there are 7 Euclid's axioms. The first one is things which are equal to the same thing are equal to one another. So how we'll see that things which are equal to the same thing are equal to one another. That is, imagine two things, that is to A and B. Okay, now A is equal to 5. That is things which are equal to the same thing. So same thing is 5 here, and B is equal to 5. A is equal to 5, B is equal to 5. Things which are equal to the same thing are equal to one another. So here obviously A is equal to B. So that is the first axiom of Euclid. And the second axiom is, if equals are added to equals, the wholes are equal. So here if equals are added to equals, the wholes are equal. So how we'll see that? Equals. See, take two numbers 5 and 5. Okay, equals are added to equals. So this is equals, 5 is equal to 5, right? And now 3 is equal to 3, right? So now add this. Okay, now we'll get 8 and 8. So obviously 8 will be the wholes. The wholes will be also equal. So that is, if equals are added to equals, the wholes are equal. Next axiom is, if equals are subtracted from equals, the remainders are equal. So we'll take the same number, that is 5 and 5 are equal. Okay, and 3 and 3 are equal. So this is equals and this is equals. So equals are subtracted from equals. So 5 minus 3, 2. 5 minus 3, 2. So the remainders will be equal. Fourth axiom is, things which coincide with one another are equal to one another. So let's say I have drawn one line segment A, B. Okay, and on top of that, coinciding A and B, I'll draw one more line segment, that is P, Q. So the axiom is, things which coincide with one another are equal to one another. So line segment AB will be equal to line segment PQ. The fifth axiom is, the whole is greater than the part. You all know that, right? So for example, consider a whole. Okay, this is a whole. Okay, and I'll take out this part. Okay, this part I'll take out. Now the whole will become only this. This part is taken out, no? So this will be always less than the whole part, right? For example, in a circle. Okay, I'm taking out this part. This is a whole. I'm taking out this part. So the circle will be now. Okay. So circle will be now. So this is always greater than the part. Whole is always greater than the part. Whole is always greater than the part. So that is the fifth axiom. The sixth axiom is, things which are double of the same things are equal to one another. For example, if 2x is equal to 2y, then obviously x is equal to y. The seventh axiom is, things which are halves of the same thing are equal to one another. So here also, if x by 2 is equal to y by 2, then obviously s is equal to y. We have seen the Euclid's axioms, and now we know that Euclid had certain assumptions, and those assumptions specific to geometry are called postulates. So the first postulate is, a straight line may be drawn from any one point to any other point. That is, from one point A to any other point, a straight line may be drawn. So assume this is another point. So from this point to this point, a straight line may be drawn. Okay, but he didn't mention that only one line can be drawn from A to B. Okay, so this is a Euclid's first postulate. The second postulate is, a terminated line can be produced infinitely. So what is a terminated line? It's nothing but a line segment, right? AB is terminated. AB line is terminated at points A and B. So the postulate states that a terminated line can be produced infinitely. We can produce this line to both ends infinitely, right? And this is the second postulate. The third postulate is a circle can be drawn with any center and any radius. And it's very obvious, right? With any radius and any center, we can draw a circle. Fourth postulate is all right angles are equal to one another. You know, right angle means what? 90 degrees. So all right angles are equal to one another. Now we'll see the postulate number 5 of Euclid. Postulate number 5 is nothing but if a straight line falling into two straight lines makes the interior angle on the same side of it taken together less than two right angles, then these two straight lines, if produced indefinitely, meet on that side on which the sum of angles is less than two right angles. Now we'll see what it is. Okay, first I'll draw and explain. If a straight line falling on two straight lines, okay, there are two straight lines. Say our first line, let's take this is our first line. First straight line BL. Okay, and we have another straight line also, right? If a straight line falling on two straight lines, right? So two straight lines are there. So let's see, let's take another line as M. Okay, so this is our two straight lines. Now it's saying if a straight line falling on two straight lines make an interior angle. So there are one more line that falls on these two lines L and M. Say this is our line N that falls on our line L and M. That is N is a straight line that falls on the straight lines M and L. Okay, and let's check how many what are interior angles. Interior angles are nothing but this angle, this angle, this angle, and this angle. Say, let's number it. Okay, 1, 2, 3, 4. So this you know what is interior angles, right? We have studied that. So this is angle 1, angle 2, angle 3, angle 4. So what is the postulate? If a straight line falling on two straight lines makes the interior angles on the same side of it taken together less than two right angles. Okay, so what is the same side of this? Same side means angle 1 and 3. So angle 1 plus angle 3, and at the same side is angle 2 plus angle 4. So interior angles on the same side if it is taken together less than 2. What is two right angles? Two right angles means 2 into 90, which is 180, right? So if this is less than, the sum of 1 and 3 is less than 180, then what it is saying? Less than two right angles, then these two straight lines, if produced indefinitely, must meet on that side. Okay, so if we produce these, okay, these lines, it meets at a point, right? Let's say this point is P. So it meets at a point where the sum of the interior angles is less than 180. So here it is meeting. So we don't know. We'll check if 2 and 4, 2 plus 4 is less than 180. So this is true. So 1 plus 3 is less than 180 because if we extend the line, it meets at a point. And now let's extend the point, extend the line. It will meet nowhere, right? It will meet nowhere. So this is false. Okay, so what is false? Less than 180 is, this is false. So what the postulate says, if a straight line if a straight line falls on two straight lines L and M such that the interior and the sum of the interior angles on one side, that is 1 plus 3, is less than 180, then if we produce the lines, it will meet at some point P. Okay, so this is the postulate number 5. Okay, this postulate has been used for several other theories in geometry. For example, we know that what if L and M are two parallel lines and N is a line that joins L and P in some point, then we know what the sum of the interior angle 1 plus 2 it will be is equal to 180, and that is why it is equal to 180, and that is why it is parallel. The distance between L and M is constant.